Good morning, children. Welcome back to the science class. In the previous class, we have gone through the chemical properties of metals and non-metals. In today's session, we are going to learn about the different methods of extraction of metals. Let's start with that. Children, let's see what's the meaning of extraction of metal. Process of obtaining a metal from its mineral from the Earth's crust is known as extraction. We know that metals are present in the soil, that is in the earth, in the form of minerals. So how to get the metal from its mineral? That is called what? Extraction. So extraction is the process of obtaining a metal from its mineral from the Earth's crust. The process of extraction involves some stages. Directly we cannot get the metal from its mineral. So to get a metal in its pure form from its mineral, we have to follow different procedures. Let's see what are the procedures. They are concentration of the ore. Concentration of the ore. Then conversion of the ore into its oxide. Reduction of metal oxide. Refining of impure metal. So these are the stages, these are the steps that we have to follow to obtain a metal in its pure form from its mineral. You know, metals are present in the form of minerals. And what is an ore? Here you heard the word ore, concentration of the ore. Ore is the mineral from which we extract a metal in an economic way. Ore is the mineral from which we extract a metal economically, means with less expenditure. So such minerals are called ores. All the ores are minerals, but all the minerals are not ores. Because we cannot extract a metal from its all minerals. Only certain minerals is useful for extracting the metals. So such minerals we call as ore. So what are the different steps involved in this? First is concentration of the ore, and the second one is conversion of the ore into its oxide, reduction of oxide, then refining of impure metal. So you may think why we want to do in the second step conversion of an ore into an oxide, and in the third step reduction of that oxide. So instead of that, why do you want to oxidize it? You may be thinking like that, directly we can refine it. No, but that's a procedure because all ores are the metals combined with certain other elements or compounds with that. So let's see one by one. The first one is concentration of the ore. The process of removal of gangue from an ore is termed as concentration. So what is concentration of the ore? The process of removal of gangue from an ore is termed as concentration. Gangue means, you can read it as gangue. Okay. So gangue means impurities. What is the meaning of gangue? That is impurities. So removal of impurities from an ore is known as what? A concentration. When an ore is mined from the earth, it contains earthly impurities like rocks, mud, clay, etc. These impurities are called gangue. So, gangue means it is the impurities like rocks, mud, clay, etc. or the earthly impurities which are associated with the ore. So that is the first step that we can do by washing. Okay. Then second one, conversion of the ore into its oxide. So based on the reactivity of the metals, different methods are used to extract metals from the ores. So the first process is concentration, that is removal of the earthly impurities from the ore, and this can be achieved by flushing with water. The ore is first making into powder and it is flushed with water so that all the earthly impurities will be removed from the ore particles. Okay, and the second step, the conversion of an ore into its oxide. We have to depend on different methods. The carbonated ores are converted into metal oxides by the process called calcination. So, if an ore contains carbonate, such ores are called what? Carbonated ores. The metal combined with the carbonate. You know, carbonate means CO3. So that is called carbonated ores. If an ore is in its carbonated form, or it can be in sulfate form, it can be in sulfide form, it can be in oxide form. Okay. If an ore is in carbonate form, then it should be converted into first into its oxide, and that is by a process called calcination. So let's see what is calcination. Calcination is heating the ore below its melting point in the absence of air or with very little air. So heating an ore to a high temperature, not up to its melting point. Okay, it should not convert into a liquid, but heating an ore into a high temperature. How? Either in the absence of air or with very little air. That process is called what? Calcination. For example, you can see here calcium carbonate. So calcium is a metal. We get calcium from the earth in the form of calcium carbonate. And that if we heat in the absence of air, we get calcium oxide plus carbon dioxide. Means when we heat it, the carbonate will get decomposed to form oxygen and carbon dioxide. And the oxygen combines with the calcium and carbon dioxide being gas will be liberated out. Another ore, that is ferrous carbonate, iron carbonate. When we heat it in the absence of air, the carbonate gets decomposed into carbon dioxide and oxygen combines with iron. We get ferrous oxide and carbon dioxide is being released. So this is how we convert a carbonate ore into its oxide. So that is why we are undergoing this step, that is conversion of the ore into its oxide, because for the extraction of a metal, the oxides ores are easy to be extracted with further steps. So all the sulfate ores or carbonate ores, all we have to convert first into oxides. Understood? The metal oxides obtained by calcination are further reduced to crude metal by heating them with reducing agents like carbon, carbon monoxide, calcium, and aluminum. So the second step we have seen after oxidation, reduction of that oxide. And the reduction of this oxide is by the process of water reducing by using the reducing agents like carbon, carbon monoxide, calcium, and aluminum. And here, the oxidose we can produce, we have learned already that by calcination, that is heating an ore in the absence of oxygen. And if we heat an ore with excess of air, if we heat an ore with excess of air, that process is known as roasting. So this is another method for converting an ore into its oxides. More air, excess air if we supply, more oxygen will be combined with the ore. So that process is known as what? Roasting. So roasting is a process of oxidation of an ore by heating the ore below its melting points in excess air. So if there is no oxygen, we call it as calcination. If there is excess of oxygen, excess of air, we call it a roast. So which are be the methods? The oxide ore is now converted. The ore is now converted into oxide ore. Now the next process is reduction of the oxide ore. And this can be achieved by heating the oxides with reducing agents like a carbon, carbon monoxide, calcium, and aluminum. These are the reducing agents that we use normally. Let's see an example. The ferric oxide, that is iron oxide. Iron oxide, when treated with carbon, we get iron and carbon dioxide. The oxide part present in the ore decompose and combine with the carbon, or the carbon reduces the oxide ore and convert into the metal, that is iron, and carbon dioxide gas will be produced. So now from the ore we got the metal, but this metal is not pure in the pure form. Okay, it should be purified again. Now from the ore we got the metal. Now to convert the oxide ores, or to reduce the converted oxide ores, again we have to use different methods based on the reactivity of the metal. All the metals we cannot treat in the same way. The metals should be, or the ores should be treated based on the reactivity. So let's see the first one. Extraction of less reactive metal. So if the metal is very less reactive, how we want to extract it? So metals like mercury, copper, and silver that are less reactive are usually found in their sulfide and halide form. So, as I told earlier, some of the metals are present in its sulfide forms or halide forms. So, which are those metals? Those metals are mercury, copper, and silver. So, these metals are less reactive metals, so they can combine only with the sulfur. And these sulfide ores are first oxidized to their oxides and then subjected to thermal decomposition, that is by heating, to obtain the crude metal, and that will be then refined to get the metal. Understood, children? This is about extraction I am doing. The less reactive metals like mercury, copper, and silver will be present in their halide or sulfide forms. So, these sulfide ores are first converting into oxides. And these oxides, if we heat again, what will happen? We get the crude metal. If we heat with any agents, we get the crude metal. For example, you can see here HGS. HGS means mercuric sulfide. Treating with oxygen, that is converting it into oxides. Okay, so HgO, mercuric oxide we get, and sulfur combines with oxygen and forms sulfur dioxide. Being a gas, it will be released out. Then this mercuric oxide HgO is then decomposes into mercury and oxygen. Understood now? Then how can we extract moderately reactive metals? So metals like zinc, iron, copper and lead. Copper can be called as a less reactive and moderately reactive metal. Okay. So the metals like zinc, iron, copper and lead are moderately reactive and occur as their carbonate and sulfide ores. Sometimes as carbonate and some more are sulfide ores. They are first converted to their oxides by roasting or by calcination and then reduced to get the crude metal using reducing agents and then refined. We have already seen carbonatos or the oxides how we are using reducing agents like carbon, carbon monoxide, calcium, aluminum and all we can use as reducing agents and we can remove that oxygen from the oxide. Then the metal can be refined, purified. So we adopt different methods for the extraction of less reactive metals and moderately reactive metals. So if the metal is less reactive, there is no need of undergoing a long process of reduction. If we heat it again, the oxide or the sulfide ore first convert into oxide ore, and if we heat continuously, the oxygen will be removed from that and we get the metal. But in the case of carbonate ores and some sulfide ores of moderately reactive metals, we have to do the process of reduction. The metals have to undergo the process of reduction by using reducing agents. Then only we can completely remove the oxygen from it. If we just heat it, the entire oxygen will not be removed from that. Understood, children? So different metals need different methods for the extraction of it. Now let's see how can we extract highly reactive metal. You have learned about the reactivity series. You know there are highly reactive metals, moderately reactive metals and less reactive metals. So metals like potassium, sodium, calcium, magnesium and aluminium, which are at the top of the reactivity series, are highly reactive. Their oxides are very stable and hence they cannot be reduced by reducing agents like carbon because the metal shows more affinity towards oxygen than carbon. These highly reactive metals shows more affinity to oxygen than carbon. Hence, their halides are subjected to electrolytic reduction. So, the normal reduction is not possible for a highly reactive metals because they have more affinity to oxygen than carbon, so they will not liberate oxygen from them. Then how we are removing it? So we can remove that oxides or their halides or their sulfides. We can remove by electrolytic reduction. So let's see what is electrolytic reduction. Electrolytic reduction is a process where a chemical change occurs by passing an electric current through a molten salt. So electrolytic reduction is a process where a chemical change occurs by passing electric current through the molten substance. So this process involves breaking up of the salt into its ions, and then ions move towards respective electrodes. You know, positive ions and negative ions are there. Positive ions will move towards negative electrodes and negative ions will move towards positive electrodes. And the metal get deposited at the cathode and the non-metal get deposited at the anode. Metal get deposited at the cathode and the non-metal get deposited on the anode. Metals produce positive ions, so they will be attracted towards cathode, the negative electrodes. So this is what electrolytic reduction. So what is electrolytic reduction? Electrolytic reduction is a process where a chemical change occurs by passing an electric current through a molten salt, that means molten ore, and the process involves breaking up of the ore into its ions, and these ions move towards the electrodes and will get it deposited. So when we do this, the metal ions always move to cathode as they form positive ions. So now we have seen that how can we extract or how can we reduce less reactive elements, moderately reactive elements, and highly reactive elements. Now the next step, that is the fourth step, is a refining of metal. So the first step was concentration of the ore, second was oxidization of the ore, third was reduction of the ore, and the fourth step, that is a refining of metal. The metal obtained is not pure. So by the reduction process or by the continuous heating process, thermal decomposition process, we get a crude metal. That metal is not in the pure form. It still has some traces of impurities in it and hence should be refined, purified to get the pure metal. The most common method of refining is electrolytic refining. So in most of the metals case, we use electrolytic refining. So why do we want to do refining process? Because even after the reduction process, the ore may contain some more impurities. So to remove these impurities, we have to refine the metal. And this is done by the process of electrolytic refining. And this process involves breaking up of the molten metal. That is, first we are making the metal to its molten form and decomposing this molten form into its ions by passing electricity. And these ions move towards the electrons. And the metal get deposited at the cathode and the non-metal at the anode. The metal thus obtained is a pure metal. So no more impurities will be there in that metal. So the common refining process of metal is a electrolytic refining. For that we use the molten metal in a tank and passing electricity through that. When electricity passes through that molten metal, it decomposes into positive ions and negative ions. And the metal ions, that is positive ions, move towards the cathode and get deposited on the cathode. And the non-metallic part will move towards the anode. So finally we get pure metal. So this is how we manufacture or produce metals from the minerals, that is from the ores. In geography, you are studying about the various minerals available in India and in other countries. And we have even industries, metallic industries, where the minerals are converting into metals. So in all that industries, these are the steps they follow to convert a mineral, an ore, into a metal. So the metal what we are using are obtained by all this process. So children, I hope you understood how to extract a metal from its mineral. Now, in your syllabus, you have to learn two important terms related to the properties of metals. We have already learned the physical and chemical properties of metals. But out of that, some of the property what we have learned is harmful to us than usefulness. And these properties are we are going to learn now. So they are corrosion and rusting. So which are those properties? Those properties are corrosion and rusting. So let's see what is corrosion. Corrosion is a phenomenon where a reactive metal in the presence of oxygen and moisture or any other chemicals undergoes oxidation to form a respective oxide. So we already learned that a metal when exposed to atmospheric air, it undergoes oxidation or metals combines with oxygen forms metallic oxides. And the formation of this oxide is known as what? Corrosion. Why we call it as corrosion? Because the process weakens the metal surfaces as the product formed after corrosion is porous and weak. So if there is an oxide coating, oxide layer on a metal, then the metal, it makes that oxide layer makes the metal what? Weak and making it porous. Porous means having small holes, openings. And commonly metals like iron, copper, silver and aluminium undergoes corrosion. We say that gold and silver, they are non-reactive metals, but silver can undergo the process of corrosion to a certain extent. You know that the silver jewels, what we wear, what we are using. After using for some time, its color will become faded. So that is what a corrosion. So corrosion is a phenomenon where a reactive metal in the presence of oxygen or moisture or any chemicals undergo oxidation to form its oxide. And the formation of oxide on its surface make the metal porous and weak. This process is known as corrosion. Now, the next term is rusting. What is rusting? The phenomenon in which iron react with moisture and form a reddish brown substance on its surface is known as rusting. So we learned corrosion. In that even iron is included. So when all the metals react with oxygen or moisture in the environment, that process is called what? Corrosion. But when we specify iron, we call it as what? Rusting. We never say rusting of copper, rusting of silver, but we say rusting of iron, not corrosion of iron, rusting of iron. So the phenomenon in which iron reacts with moisture and forms a reddish brown substance on its surface is known as rusting. And we know what is that, a reddish brown substance formed. That is the rust. Its chemical name is hydrated ferric oxide. What's the chemical name of rust? Hydrated ferric oxide. It's called hydrated because rust is formed only in the presence of moisture. So water content is there. That is why it is called what? Hydrated ferric oxide. We have learned this in some other chapter. I hope you remember. Water of condensation. We studied. So we told in a molecular formula. We put a point and write water H2O with a certain number. No? So the rust is also formed like that. Then how can we prevent rusting? Rusting is not good for us, or corrosion is not good for us. No, it's a disadvantage of metal. So there are methods to prevent this rusting. So let's see what are they. The most important one is painting. Iron articles are coated with paint, which in turn act as a barrier and prevent the contact of iron with air and moisture. This prevents water rust. So we know that almost all iron materials we paint and use. So before using, we paint the iron materials. So this painting prevents the contact of iron with the moisture in the atmosphere and thus prevent it from rust. And the second method is galvanizing. What is that? Galvanizing. A more reactive metal like zinc, tin, nickel or chromium is coated on the iron surface by dipping iron in these molten metals. So, one method is coating with paint. The other one is some metals like there is more reactive metals than iron. The metals which are more reactive than iron are molten and this iron material is dipping in that molten metal so that a coating will be formed on its surface thus prevent it from rusting. When these more reactive metals on the surface comes in contact with the moisture, it undergoes oxidation and act as a protective layer, preventing the oxidation of iron or preventing the iron from rust. Understood, children? So this is called a galvanization or galvanizing. A metal like iron is dipped in a molten form of more reactive metal than iron, thus making a coating of more reactive metal on the surface of iron, which prevents iron from rust. The next method is applying grease or oil. Iron articles are coated with grease or oil, which act as a barrier, preventing the contact of air and moisture with iron. We know iron articles or gates, shutters and all we coat with grease or oil. So that this coating of grease or oil, the layer of oil or grease, prevent the iron from coming in direct contact with moisture. So we can prevent rust. And one more method, that is alloying. You might be heard the word alloy. An alloy is a homogeneous mixture of two or more metals or a metal with a non-metal. So what's an alloy? Alloy is a homogeneous mixture. Homogeneous means all the particles are of the same phase. Homogeneous mixture of two or more metals or a metal with a non-metal. So how is this alloy formed? An alloy is made by mixing its constituent metals or metals and non-metal in its molten form and then cooling at a room temperature. So to produce an alloy, we have to melt separately the different metals or the metals and non-metals and then mixing them together and allowing to cool at room temperature. The resulting metal, what we get, that is called a alloy. An alloy is more resistant to corrosion. Why we want to make alloy? Because alloys are more resistant to corrosion or rusting. So whatever we have learned, the preventive measures of rusting, that's applicable even for corrosion. For example, stainless steel. We know the steel vessels that we use. No? Steel vessels. Stainless steel or the steel what we are using for the furnitures. A mixture of iron and carbon. A mixture of iron and carbon. So iron is molten, carbon is molten separately. Carbon is a non-metal and iron is a metal. So both are mixed together and cooled, and the resulting product what we get, that is what we call steel. We know iron will get rusted fast, but steel will not get rusted. Then another one alloy is duralumin. Dula, Duralumin is a mixture of magnesium and aluminium. Duralumin is a mixture of magnesium and aluminium. So we are melting both separately and mixing them together and cooling at a room temperature. A commonly used alloy in our houses is brass. Brass, the deepa, what we use in our houses. formed of brass. That is, it's an alloy of copper and zinc. It's an alloy of copper and zinc. So, what is the advantage of alloys? Alloys are more resistant to corrosion or rusting. So by adopting all these different methods like painting, galvanizing, applying grease or oil, or converting the metal into an alloy, we can avoid the metals from undergoing corrosion or rusting. And it is useful in our daily life. So these are the topics that you want to study in this lesson, metals and non-metals. And there is a very important diagram in your textbook, that is a refining of copper. You have to practice that diagram. Okay, children, I hope you understood. And let us revise this topic in the class so that it will become clear for you. Okay, bye.